Dear students, in this module, we'll look at how mass spectrometry can be employed in sequencing proteins. There are situations in the lab where you have to actually sequence unknown proteins. Of course, we have the Edman degradation process by which you can do that, but there are many limitations with Edman degradation, such as it does not allow you to sequence larger proteins and that it is a slow process, it is a tedious process. So to your rescue and to my rescue is the mass spectrometry based proteomics. So it can help you to sequence very big proteins as well as look at their post-translational modifications and to quantify them. So it's an extremely powerful technique that is available to us now. So the first thing that you need to recall is that the protons or electrons can actually be added on top of a protein. So in such a situation, the protein will become a charged particle. And then, if you place this charged particle into a magnetic field and you impart some velocity to it, it will get deflected. It will diverge from its path due to the effect of the magnetic field. The usefulness of this deflection comes in when we realize that the degree of deflection is actually directly proportional to the momentum or the mass of the protein. So if you can somehow measure the degree of deflection for small and larger proteins, then you can arrive at their mass. And once you have the mass, then you can fragment them and look at their sequence. So as I just said, the key principle is that the degree of deflection is proportional to the momentum, which is actually the product of the mass and velocity of the protein. The underlying physics of this phenomena, as you would already know, comes from the Lorentz force and the Newton's second law. So, given in these equations, F equals ma, where m is the mass of the protein or the ion, right? The charged protein. Q here is the charge that you have added onto the protein. B is your magnetic field that you have placed around this moving protein. V is its velocity with which it is moving, and E is the electric field. So, if you just take the ratio, then you can have an expression wherein you can actually measure the mass over charge ratio for any protein that you have with you. So, given that you know this mass over charge ratio, then you can arrive at the mass of that protein. For instance, if charge is 1 in this, if this Q equals 1, then this ratio is essentially equal to m, or simply the mass of the protein. So this is how you can arrive at the mass. So once you have measured the molecular weight or the mass of a protein, then you can fragment it into its peptides and measure their molecular weight as well, and onwards towards sequencing them. The components of a mass spectrometer, the first thing that you need to do, as I just mentioned, is to inject your sample and then you ionize it by having an ionization source placed very close to the sample. And next, you analyze the mass which is there in the sample molecules, and you detect these particles which are now carrying a charge and hence are ions. And you have computational tools or bioinformatics tools to actually arrive at the sequence of these proteins. So this is a very nice and interesting application for you. The overall schema of the mass spectrometer, as I just mentioned, includes the ionization process, the mass analyzer. Of course, your sample is here, and then it travels into the ionizer, gets the charge, gets analyzed, gets detected here in the mass detector, and then here you are, the bioinformatician, You analyze this information and you arrive at the sequence of the protein. The important thing or the take-home message from this short introduction to mass spectrometry in sequencing proteins is that one, you have to charge the protein. So once you have a protein carrying a charge, it can move in a magnetic field and will therefore be deflected to a certain degree. And that degree is proportional to its mass. Moreover, these deflections can actually be measured. And once you can measure these deflections, you can talk about the mass of these proteins onwards for sequencing.